In this video, we will go through one example of conducting a hypothesis test. So first, we have to identify and write down the null hypothesis, what we're assuming is true about the mean, then write down the alternative hypothesis, what we, the researchers, think might be going on, use the alternative hypothesis to figure out is this a right-tailed test, a left-tailed test, or a two-tailed test. Find the test statistic, so calculate your z or t-score, and then the corresponding p-value that relates to that test statistic. We'll use our sample evidence, that is our test stat with its p-value, to draw a conclusion regarding whether to reject or fail to reject the null hypothesis. Now, the way we're going to do that is to compare the p-value, the area, with our level of significance, our alpha value, and decide, do I reject or fail to reject? The last thing we do is write a conclusion, and our conclusion is always, do I have enough or not have enough evidence to reject the null hypothesis? Now, we need to say that in specific terms, not just reject the null, but specific to our problem. So here's example 4, and we'll work through example 4. A research meteorologist has been studying wind patterns over the Pacific Ocean. Based on these studies, a new route is proposed for commercial airlines going from San Francisco to Honolulu. The new route is intended to take advantage of existing wind patterns to reduce flying time. It is known that for the old route, the flying times for a large four-engine jet has a mean of mu equals 5.25 hours. 36 flights on the new route have yielded a mean flying time of 4.9 hours with a standard deviation of 0.6 hours. Does this indicate that the average flying time for the new route is less than 5.25 hours? Use a 5% level of significance. So the first thing we want to do is figure out what is our null hypothesis and what is our alternative hypothesis. Well, if we notice, our population mean is assumed to be 5.25 hours because that's what it's always been. So that's going to be our null hypothesis. Mu equals 5.25 hours. Our alternative comes from the question being posed. Does this indicate that the average flying time for the new route is less than 5.25 hours? That tells us our alternative should say the mean is less than 5.25 hours. So based on that, we know that this is a left-tailed test. If the alternative says less than, it's a left-tailed test. The next thing we have to do is find our test statistic so that we can find the p-value. Now, the test statistic is either a z-score or a t-score. So let's look up here and determine, is this z information or is this t information? Our sample size is 36, and this sample has a mean flying time of 4.9 hours with a standard deviation of 0.6 hours. Now, grammatically speaking, the 4.9 hours and the 0.6 hours belong to the sample, so this is going to be a t problem. So we use our formula, and this subscript of O stands for observed. So our test statistic is sometimes called an observed value. So here we have our sample mean, 4.9, minus our population mean, which we get really from our null hypothesis up here. Then we divide that by S of x bar, which is the standard deviation of the sample divided by the square root of n. And we get a t-score of negative 3.5. Now we need to find the p-value, the area in the tail. So we can either use choice 6 on a calculator, TCDF, or we can go to Desmos and use t-distribution. Now these choices are going to ask you for your lower bound and your upper bound. And if you use your calculator, it's going to give you this number here. Remember that this e negative 4 means times 10 to the negative 4th. So our p-value then is 0.0006. That's a pretty small p-value. We're going to compare our level of significance, which our problem indicated here was 5%. We're going to compare our level of significance and that p-value that we just found. So here's our p-value. We're comparing it to 0.05. Now 0.0006 is less than 0.05. If p is low, HO has to go. So we should reject the null hypothesis. We should say that the mean is not 5.25 hours. Our analysis has indicated that that's incorrect. We do have enough evidence then to say that the mean flying time is not 5.25 hours.